For the homework in Lab 8 on algorithms, you're given the task of taking an algorithm and implementing it inside of your code. Let's go ahead and take a look. It's the rock, paper, scissors game, often called Roshambo. And we want to take this algorithm. So I'm going to do Control A, Control C, and I'm going to copy that so that I can implement this algorithm. Go ahead and open up Eclipse. And let's make a new class inside of a project folder. And we'll go ahead and we'll call it Roshambo. You can name your class whatever you want to name your class, but always follow the Java standard of capitalizing that class name. I'll go ahead and check mark to write main in there for me. I'll then click Finish. It'll make that class. Remember, you can always get rid of that default to do. I'll go ahead and paste in my algorithm. Remember to get rid of any extra lines to keep your code nice and neat. And let's start implementing this algorithm. So we'll start here with step 0. And I'm going to go ahead and copy and paste this algorithm as I'm writing it. You don't necessarily always have to copy and paste your algorithm as you're writing it, but since we're learning how to take an algorithm and implement it in code, I'm going to go ahead and paste each line of this algorithm as I implement it. Voila, we've implemented step 0. Now I made user's choice and computer's choice as integers. In the following video, I will go ahead and make user's choice and computer's choice strings and show you how to implement it if you did choose to have user's choice and computer's choice inputted as strings. All right. Let's go ahead and implement step 1. Step 1 says, ask the user what choice they would like, rock, paper, or scissors. So let's go ahead and implement that. We'll ask the user. So remember to type in SYSO, Control, Spacebar, Enter to write system out print line for you. And we can go ahead and say, would you like to choose rock, paper, or scissors? All right, now to get user input, I'm going to go ahead and make a scanner object. You can name that scanner object whatever you want, but a common name is keyboard. We'll tell that scanner object to connect to the system input, which is our keyboard. We need to import that scanner library so that our code knows what a scanner object is. So hover over scanner and choose the first quick fix if you would like Eclipse to write this line of code for you to import that class from the java.util library. All right, let's go ahead and use that keyboard object. Remember to double click, Control C, click, Control V. Use your dot operator to bring up your methods of the scanner class. And we can go ahead and say next int. And we'll grab that input as an integer. And we'll have the user type that in. So we're going to place whatever integer they typed in at the keyboard into user's choice variable. Let's tell our user to go ahead and input an integer, a 1 for rock, a 2 for paper, and a 3 for scissors. Oh, we already implemented the next step, which was get the user's choice. This is where we're getting our user's choice. Let's implement step 3. Make the computer's choice of rock, paper, or scissors. Okay, we'll have the computer choose rock, paper, or scissors. Now, how do you make a computer choose something? And we're going to go ahead and use math.random. Now remember that every computer language has a random function, usually in the math library, and that they usually work the same way. Because you can never have a game without random. Think how boring of a game it would be if nothing was random. Let's look at how math.random works. It returns a double value with a positive sign greater than or equal to 0.0 and less than 1.0. So it's between 0 and 1. It returns a decimal value between 0 and 1, 0 inclusive and 1 exclusive. All right. With this knowledge, we can say, how is that computer going to choose a 1, a 2, or a 3? And here's how you make that decimal value into a 1, a 2, or a 3. First, you take that decimal and you multiply it by the range of numbers you would like. We would like it to choose from 3 numbers. So we're going to multiply it by 3. Now this will give us a number between 0, inclusive, and 3 exclusive, so 2 point something. So either 0 point something, 1 point something, or 2 point something. Now we're going to add 1 to that number. So now we have a decimal number between 1 inclusive and 4 exclusive. So 1 point something, 2 point something, or 3 point something. Now we want to get rid of the point something. So what we're going to do is we're going to typecast this number into an integer. So it'll drop the decimal places. So now we'll have a number between 1 and 4. So we're going to get the number 1, 2, or 3. To see this happening, let's go ahead and output to our user whatever the computer chose. And we'll go ahead and output computer's choice. Oops. Control C and Control V. Go ahead and run him. And it asks us, let's play Roshambo. We'll choose 1 for rock, and the computer chose a 1. Now this game would play a lot better if it outputted rock, paper, or scissors here, and not just a 1. So I'm going to do a little bit extra. Note that you could have gotten full points on this assignment without doing this part, but this is a good way to do this, and it's good review of our switch statements. Let's use a switch statement to change our computer choice from a 1, 2, or 3 into the word rock, paper, or scissors. So we'll take computer's choice as an integer into this switch statement. And then we'll go ahead and put our case of 1, and we'll output the word rock. And then we'll break. And then we'll make our other 2 cases. So Control C and Control V, our case of a 2 or our case of a 3. We'll output paper or scissors. Now note that I don't need a default case because I know that my math.random and the way that I made this equation will always make computer's choice a 1, a 2, or a 3. Now I'll get rid of the ln part of my system.out.println so that it won't print the end of line character, but will instead print computer chose, and then come down here to my switch statement and finish that sentence with either rock, paper, or scissors, and then put my end of line character on there. So go ahead and run and test your code. Remember to program in parts like I am doing and test as you go so that you can have a working program at the end. So we chose a rock, computer chose paper, and it seems like everything is functional. Let's go ahead and implement step number 4 then. Start implementing the logic. If the user's choice equals the computer's choice, now remember that I can use this equals operator because these are integers, and I can use equals with integers. Remember that you can't use equals with strings, and so in the following video, I implement this algorithm with strings And you could see that we use the dot equals ignores case instead of the equal equals operator. All right, so if user's choice equals the computer's choice, output it's a tie and end the game. So I'll go ahead and do system out. I'll put it is a tie and go ahead and end my game. Now system.exit 0, I'm going to go ahead and use that here now. It's not the most elegant way to end your program, but it will end your program right there. Let's implement step 5. If the user's choice equals scissors, then perform the rest of these steps. So I'll come down here and paste that in there. Remember, I can always do a Control-A, Control-I to indent correctly. You can always minimize these windows over here to make your workspace bigger. All right. Now, since I wrote my algorithm very pseudocode-like, I can do a lot of copying and pasting. So if the user's choice equals scissors, then I need to check in this sub-step if the computer's choice equaled a rock, then now I'm going to output more than one line of code here. I mean, output one line of code, but execute more than one line of code. And I'll go ahead and output that the computer one, so SYSO, control space enter, the computer one, and end the game. Here's my second line of code. So I'll do a system.exit 0. Now notice that I'm getting red underlines here for my scissors and my rock. It is because I'm saying, hey, this user choice, which is an integer, equals this word scissors. Now, if I'd like to, I could make scissors into an integer. So scissors was 3 in my code. But note that it makes it hard to read now. And this would have been an acceptable way to program your code. But let's see how we can make our code more readable. I can make my code more readable by making an integer that I call scissors and go ahead and set it equal to 3. I then could make a variable I call rock and set it equal to 1 and a variable of type int called paper that I set equal to 2. All right. So now when I say user's choice equals scissors, I'm still comparing integers, but it makes my code more readable. Let's see, where were we? We were at the else if part here. Else if, I know that I'm going to execute more than one line of code after my else if, so I'll put my curly bracket in there. And I'll go ahead and copy and paste my comparison that I need to perform. And here is where I can copy and paste my output line, my system exit 0, but now the user has 1. Or maybe even better, just say U1 and then exit. I'll do a Control-A, Control-I to indent correctly. And it's looking pretty good. Now you might have noticed in this algorithm that I can make it a little bit more efficient by making this an else statement instead of an else if. I know that this is the only choice that there could be, and so making this comparison is a little bit redundant. Because if the user's choice doesn't equal the computer's choice, and the user's choice was scissors and the computer's choice was rock, then the only other way that I would ever get to this statement is if the computer's choice wasn't rock and didn't equal the user's choice, which means that it's paper. All right, let's implement step 6. All right, so now we have an else if. Now remember that this else if belongs to or is connected with this if. So if this is not true, it'll come down and check, to see if this is true. If the user's choice equals paper, what do we want to do? We want to check if the computer's choice equals scissors. In fact, we're going to do something so similar to this. I'm going to go ahead and copy and paste this in here. Just make sure to change this computer's choice equal to scissors. And change your output line if you're copying and pasting the algorithm. Copy and paste this algorithm line in there. Here's my else if. My else if is so similar to this. Then I'm going to go ahead and copy and paste this down here. And then I can take this line of my algorithm. Remember, you didn't have to copy and paste your algorithm in here. And I'm going to go ahead and put it here. Make sure I change my algorithm. And for the same logic that I made this else if into an else, this else if can also just be an else. Do a Control A, Control I, and voila, step 6 is implemented. Let's go ahead and do step 7. All right, we have another else if, and guess what? This else if is a little bit redundant too, because remember that this else if is connected to this else if, which is connected to this if. And if the user's choice wasn't scissors, and if the user's choice wasn't paper, then the user's choice has to be rock. And so we could get rid of this if part if we wanted to, but remember that it would look like this. All right. Let's go ahead and implement the rest of step 7 here. Now the rest of step 7 looks very similar to steps 5 and 6. So if you want to, you can copy and paste. Just remember that when you're copying and pasting, that you are copying and pasting correctly and implementing the algorithm as it is written, because I know that this algorithm works. All right, I can copy and paste the else part if I would like. Remember that you can type this out too if you'd really want to. And of course, if you were not copying and pasting your algorithm in here, you can copy and paste a little bit faster even. All right, oh, get rid of this. Control A, Control I, indent correctly. Now the last step in our algorithm is to go back to step 2, but before we do that, let's go ahead and run our code and test it. We'll go ahead and enter a 1 for rock. The computer chose paper and the computer won. Now remember that you'll want to test your code a few more times and get down every branch to make sure that it is working. The computer chose paper, it's a tie since we chose paper as well. Computer chose scissors and we chose paper. Yep, the computer indeed won. Now let's implement that last step, which says go back to step 2. So if we would like to go back to step 2, here's our step 2, getting our user's choice. Let's go ahead and take all of step 2, so we'll make this part our do part. Make this into a do while loop, which makes sense. So I'll go ahead and put my do part up here before step 2, since I want to include step 2. And put my while part down here. Now just to test it, we'll just make this a while true loop. Do a Control A, Control I, and make sure that all the code that I expect to be in that loop is indeed inside of our loop. Go ahead and run that code, and we can choose rock, and we can choose, oh, actually, to get this to work correctly, we have to take out our system.exits because this was ending our program. And now that we want to repeat our program after they have won, or after the computer has won or we have won, we'll go ahead and take out the system.exits, which ends our program. Now note our code will still run correctly because of the way we set up our algorithm within the if-else-ifs. We'll go ahead and choose rock, and then we'll choose rock, and then we'll choose rock, and then we'll choose rock. And the next step then to make this into a better game would be to add a score and keep score of who is winning and who is not winning. All right, so that is a simple way to implement this algorithm. In the next video, I'll show you how you can improve upon the gameplay of this algorithm. But that is the implementation of the rock, paper, scissors algorithm.